This is Trampus. I'll be doing the multi-sim port.
Hey, this is Josh. Part of Team C. I'm going to be doing the old school version on...
My name is Mark, and he explained everything, so let's get this started.
This is how we create the circuit that we're using to test within multi-sim. First, you place your title box. All right. Next thing we do is we're going to place our components. So we'll start off with the power source. The ones we chose is a 680, so I'll place that one right here. And then we chose a 4.7K. I will rotate this one. There we go. The next thing we do is connect our wires, so pull our ground into it. Next, we're going to change this color to black so we keep it all sorted correctly in our heads. Then we're going to need a measuring test tool. We come over here to our oscilloscope, the 2-channel and not the 4, and I'll place this right over here. The A I'm going to use to test over the resistor, so I'm going to connect this one to here, to that side of the resistor, and the negative to the negative side of the resistor. I'm going to use channel B to test the voltage source. So I'm going to take the positive side to the positive side of here. I'm going to use the negative side, and I'm going to run this over to this node here. All right, so that sets up the circuit. The next thing we're going to do is run our test. And let me make sure I change this to the correct settings so we can look at it. So we're going to change this to the 2 milliseconds time-based division. So let's go down to 2 milliseconds. We're going to change our voltage on to 10. So the first test we're going to make is for voltage peak to peak. So I'm going to take out the green one because we're not going to use over the resistor. So I'll see which one's set at AC. And here's our voltage for our voltage source. Peak reverse so everybody can see it. Run the test one more time. So now that we've set our voltages for peak to peak, it's indicating down here that's 11.314 from peak to peak. Alright, and now the next measurement we're going to do is the 4 volts RMS. Take the peak, one peak, which is 5.7. And we're going to divide that by the 0.707, so 0.657, and we multiply that times 0.707. That's going to give us our 3.99, or our 4 volts RMS that we set up for our voltage source. We can see the time set from cycle to cycle, so we'll start off second cursor to the end of this cycle, and then we'll set this one to the beginning of the cycle to there, measuring one complete cycle with the positive and the negative. So that goes there. It shows our time is 10 milliseconds. Frequency, you take your time milliseconds. Since it's milli, you go back 3, that would be 0.01. 1 over 0.01 divided out gives you the 100 hertz that we've confirmed for our voltage source, which is the over resistor. We'll turn off this one, and our green is over the resistor, so our resistor gets peak to peak. So our voltage peak to peak is 9.88, and for peak it is 4.92. Measure the RMS, we take the 4.92, we multiply that times the 0.707, that gives us 3.49, exactly what we've got as far as our root mean square for the voltage. And also the same thing, we've got 5 milliseconds. Just for peak to peak, we want to do it for the whole cycle to find frequency here, and it shows 10 milliseconds. So there again, if we take the 10 milliseconds, put 1 over 0.01, divide that out, it would be 100 hertz. So that concludes my portion of how to do the testing, setup, and everything in our multi-sim on the breadboard and the oscilloscope.
Alright, this is how we set up the AC circuit on the breadboard. We connect the 4.7 resistor to the ground section, then we connect the 680 to the positive. Connect it together. Alright, Now we can start by connecting the power source. So we can connect hot to the positive side where we connected positive, and we can connect ground to the ground side where we connected ground. We don't have to. Positive to positive again, and negative to negative. So we turned on both the power source and the multimeter to AC world. We're gonna extend the range, and for 100 hertz is already at 4 RMS. So it's perfectly on the same RMS as the video. We can turn on our oscilloscope, and this is our oscilloscope tool here. Voltage source, it's gonna be in parallel to the whole thing, like that. So I'm going to be measuring the old school way, old ones here, peak to peak, RMS, period, and frequency. So for this machine, we measure the boxes. So right here, peak to peak would be 2 volts per box. 0.002 times 5 is going to equal, well, we know here 2 times 5 is 10. So milliseconds, 10 milliseconds is 1 second. So we know that 1 second is the period for 1 cycle. See how many boxes are from here to here? So it's 1, 2, 3, 4, 5, 6 boxes. A little under 6 boxes. So that means our volt peak to peak is 6 times 2. And 6 times 2 is obviously 12. So 12 is our peak to peak. RMS. Now this is going to require some calculating here. RMS value from the peak to peak. We got peak to peak, and it's equal to 12 volts. So now we have to divide that in half, and RMS is equal to VP times 0.70. And so 6 times 0.70, we'll do it on the calculator real quick. Around 4.2, it's a little off, but you know our RMS value is 3.9 from the multimeter. So it's a little off from oscilloscope, but that is how we get old school RMS without clicking any buttons. Period in time, it says right here also that each box is 2 milliseconds. So from here to here, if we see, it's right in the middle of this box, so this is going to be a half a box, and this is going to be a half a box as well. So this is 1 box in total. 1 box, 2 box, 3 box, 4 box, 5 boxes. 5 boxes are times 2 milliseconds. And 2 milliseconds is 0.002. 2 milliseconds times 5 is actually 10 milliseconds. So for frequency, it is F equals 1 over the same equation that TJ did, and it equals 100 hertz. Because we already received the data old school way that 10 milliseconds is equal to the period. So now we know 100 hertz. Now we have to find the resistor value. So what we could do is just pull this off real quick and put it onto this. And if you see it changes here, this is the resistor values now. So now we can measure peak to peak the same way. We'll just use the same calculations. They're going to be different, obviously. But peak to peak here is going to be from here to here. This is around half a box on both sides. So this is going to be 1 box, 2, 3, 4, 5. Actually, 5 boxes. So 5 times 2 is going to be 10 peak to peak. Peak for the resistor. It's 2 volts lower. We divide it in half, that's VP. And then we multiply that by 707 to find the RMS. 3.5, so this is the RMS value for this resistor here. And for frequency, it doesn't change because here we see that the hertz are 100 hertz. So it's going to be the same 10 milliseconds. This doesn't change. So we already found that value. So it's going to be 10 milliseconds and it's going to be 100 hertz. So that's how you find those values with old school.
We're about to start with the new school method. We're going to measure the voltage source. Right here, we're going to show you how to measure VPP. Press measurement. Understand? Then we click voltage. We scroll down, all the way down to VPP. By the show of this, it shows 11.4 voltage. Okay. Next measurement, we're going to do RMS. We scroll down, we press voltage. We scroll down, P going down, until we see RMS. We're going to see 3.9 fluctuation voltage. Alright, click it again. We're going to go to time. We're going to find a period. The period is 10 milliseconds. Alright. And after that, press on it again. Find frequency. We see it's 100 hertz. Alright. Then after that, we're going to change it to the second resistor. I'm going to clear this out. I'm going to change it. Oh, you see how it changed right here? After that, we're going to find VPP, at measurement, then voltage, then scroll down to VPP, clicked on it, same measurement, 10 volts. After that, we can go to VRMS, click that, voltage, she's going down, click it, 3.4, fluctuation at 1. Alright. Then after that, we're gonna measure period. We're gonna go on time, click on period. We're gonna see 10 milliseconds. Alright, now after that we're gonna clear everything out. We're gonna click time. We're gonna find frequency. Then we see 10 hertz. And after that, clear everything down, and that's the end of our project.
We're all saying goodbye.
Yeah,
All right,
even
we're done.
Deshaun.
Yeah, see ya. Okay.